Okay, let's start. Let's start our seminar, and in the lecture. Now, our seminar divided into parts. First of all, a change coordinate system problem, and let's start from the following problem. Problem 1. In a trapezoid ABCD with BC parallel AD, we have the ratio BC AD is equal 3, 4. Let E be the midpoint of AD. Suppose extension of the side of the sides AB and CD meet at F. Given coordinates x prime, y prime of a point relative point M, relative coordinate system S prime FBFC. Find the coordinates of this point in the old coordinate system as A, as E, B, E, C. A, B, C, D. And let E be the midpoint of AD. E, AB. F, this point, the point of intersection of the straight line AB and CD. BC, the ratio BC AD E is equal ED. And we have old coordinate system S E EV EC. Let E1, E2, and we have the new coordinate system S prime F, FB, FC. And our claim to find the relation between the new coordinate system and the old. More precisely, we must express vectors FB, FC as a linear combination of the vectors AB and AC. AB and AC. Let's try to find the solution. How to express this one in terms of this one. We have two similar triangles, AFD and BFC, and this one is equal 3 ones, and this is equal 4 ones. And we can calculate the ratio of this one and this one. This one and this one. And also we have the vectors AB and AE. And let's try to express these two vectors in the term on this. And we can try to solve the problem in two steps. First of all, express this vector in terms of this coordinate system, and second, express this vector in terms on this and this. The first step, let's start. We can calculate EB and ED in terms of E and AB. Easy to see that EB, oh, I'm sorry, EB maybe you will try to solve and express. No. What's the idea of this solution? We have two coordinate system, and we have two bases. First of this basis, EB and EC, and the second FB and FC. And our claim to express the second of this basis in terms of the first. And how to express, first of all, these vectors in terms of this. How to express can be this length is equal to this is equal 3. These triangles are similar. And we have the relation then AF is equal BF, the length this side, the ratio of the length this side to this side is equal the ratio of this side to this side, because these triangles are similar. And this ratio is equal 4 to 3. And because this ratio AF BF is equal 4 3, and the ratio AD to the BC is equal also for 3. Let's write some relation between these two vectors. Let's express, let's start with a new basis A, E, and AB, and let's try in the terms of these vectors express this one, the vectors of the new basis and the old basis. And we can start with the basis in the third basis. We can use the third basis AE and AB. And the terms of this basis we can express this one and this one. Let's start. EB let's E1, E2, U1, U2. And let's EB is equal E1. And let's try express EB, these vectors, in terms this one and this one. EB is equal AB minus AE. And we have the first vectors. The second, EC, E2. These vectors is the difference, this one and this one. E2 is equal AC minus AE. But AC is equal AB plus BC. But BC is 3 ones and AE is equal to 2 ones, because BC is equal AE times ratio 3:2. And we obtain the difference AB minus ratio 1:2 AE. So we obtain the following expression: AB minus AE. And we obtain expression this, the vectors of the old bases in terms of the new bases. And we can express vectors AB in terms E1 and A2 using this equality. How to express?
Shouldn't AB be AB plus 1 over 2 AE?
AB.
AC.
Let's check. AC is equal AE. I'm sorry. AC minus AE, E2. These vectors is a difference, this one minus this one. But AC is sum AB plus BC. AC, AB plus BC minus AE, this one. And this one is the sum AB plus BC. But BC is equal the ratio AE times the ratio 3:2 times AE, because AD is equal 4 ones and BC is equal 3 ones, because half of AD is 2 ones and BC is equal 3 ones. And the ratio, this length is ratio 3:2. And we will use this simple observation and obtain this system of the equation. And we can express this vector in the terms of this. We can subtract from the second equality the first equality. AB and AB killed one another, and minus half AE minus AE is equal half AE is equal difference minus E1 plus E2.
Professor, it's the last line you wrote AB minus 1 over 2 AE. Not here, the last line.
This equality.
No,
right,
the last line. The last line.
The last equality. This?
No. Before this, before. Down
Before?
here, down.
Down, this?
Yes. Shouldn't this be plus 1 over 2 plus it's
let's repeat our calculation. E2, this vector E2. I'm sorry. The E2, I'm sorry. E2. E2 is sum this one plus this one. Oh, no. E2 is the difference. This one and this one. Excuse me. AC minus AE. Are you agree with it?
Yes.
Yes. Is right. Yes, AC is a sum AE plus I'm sorry. AC, I'm sorry. Okay, you're right. AE AC is the sum AE plus EC. I'm sorry. You're right. Yes. AC is the sum AE E2 AC minus AE. AC AB plus BC. AB plus BC minus IAE. AC maybe a more simple way. AC is equal AE. No. We can other way to express this one. AB plus BC. We must use this one. Excuse me. Yeah, okay. This one, AC is the sum AB plus BC. AB plus BC. AB BC is equal the ratio 3 to AE, because this vector is parallel this, and the length of this vector is equal the ratio to 3 times this vector, and we obtain that the vector BC is equal to the ratio 3, 2 times AE. And we obtain AB plus the ratio 3 to AE minus AE. And after simplification, we obtain the sum AB plus half AE. Plus. Plus. Thank you. AB plus. This one, is it? AB plus. Yes, thank you, thank you. Thank you. And E01, AB minus AE. Oh, okay. And we obtain the ratio 3 to AE is equal minus E1 plus E2. And AE is equal minus the ratio 2, 3 E1 plus the ratio 2, 3 E2. AE. We express in the terms E01 and E2. And AB let's multiply the second equality on 2 and adding the first equality. And we obtain 2AB plus AB3AB is equal to 2E2 plus E1. And divided the ratio, we obtain the second formula. AE is equal minus the ratio 2, 3 times E1 plus 2, 3 times E2. And AB is equal the ratio 1, 3 times E1 plus the ratio 2, 3 times E2. And we obtain the expression for the vectors AE and AB. And let's try to express vectors U1, U2 in the terms of these two vectors. Easy to see that vector BF is equal minus U1 is equal BF is equal the ratio 3, 4 AF. 3, 4 AF. AB is a difference AF minus BF. AF minus BF the ratio 3,4 AF is equal the ratio 1,4 AF AD, and we can conclude that AF is equal 4 AB, 4 times AD, and we can substitute this equality in this and obtain 3AB. BF is equal 3AB, and the vector U1 is equal minus 3 times AB. 3 times AB. You can express the first vector. The second, FC. FC is equal minus U2 is equal FC. Minus U2 is equal FC is equal the ratio 3,4 DF. DF is equal AF minus AD. AF minus AD. AF is equal 4AB. 4AB. AD is equal to AE. Minus 2AE. And we express also the second vector U2, which is equal minus 4AB plus 2AE. And we can substitute the expression for the vectors AE and AB in this two equality. And after substitution, we easily obtain the following equality: AB minus 3 AB, the ratio 1,3 E1 plus 2,3 E2. Minus 4 AB, minus 4 AB, the ratio 1,3 E1 plus 2,3 E2 plus, oh, I'm sorry, 4. I'm sorry, it's right. AB. That's right. Plus 2 AE minus the ratio 2,3 E1 plus 2,3 E2. Let's check this equality, and we obtain the following equality: minus the ratio minus 4,3 minus 4, 3 minus 8, 3, 1 minus 8, 3 plus 4, 3 minus 4, 3 E2. And the first ratio is equal minus E1 plus 2E2. And we obtain the following relation between two bases. The first vector E1 is equal minus E1 plus 2E2. E2 is equal the ratio minus A3 E1 minus the ratio 4, 3 E2. Let's check this expression. The first step, we have expressed the vectors of the new basis by the vectors of the old basis. And let's compare. Let's find the coordinates of point F in the terms of the old basis. Easy to see. The coordinates of the point F in the old basis are equal to the coordinates of the vector EF. Let's express EF in the terms AE and AB. Easy to see. EF is equal difference AF minus AE. And AF is equal for AB. And we obtain that the EF is equal for AB minus AE. AB.
Sorry.
Yes.
Why do we need EF? Why do we need a?
Yes. F is a new origin. The origin of the new coordinate system. And we can obtain the coordinate of this new origin in the old basis. E.
Okay. So sorry, so E was our origin, right?
Yes, and we try this expression in the two steps. First step, we express the vectors EF in terms AE and AB, and the second step, we use the obtained formulas for AE and AB in terms of the old basis, and substitute this expression in this one.
Okay, got it. Thank you.
Yeah. AB. The ratio 1, 3 E1 plus 2, 3 E2, and AE is equal minus the ratio minus 2, 3 E1 plus 2, 3 E2. And after simple calculation, we obtain the ratio 4, 3 plus 2, 3. 6, 3. 6, 3 is equal to 1, 8, 3 minus 2, 3, 6, 3, 2e2. Oh, I'm sorry. 4. Excuse me. Mistake. 4, 3 plus 2, 3, 10, 3. I'm sorry. The ratio 10, 3. And 4 minus, yes, it's right. And we obtain the expression for the point O in the coordinate f in old coordinate system is equal these numbers, the ratio 10, 3 and 2, the coordinate of the point f. And we can use the formula which expresses the coordinate of the arbitrary point M in the old coordinate system in the terms of the matrix P EU S plus Fs. We can use the formula which was obtained on the lecture, and the matrix P EU is equal this coefficients of this expression which we transpose minus 1, 2, minus the ratio minus 8, 3, minus 4, 3. This exact form for the transition matrix. And we can use this formula, and after simple calculation, we obtain the answer on this problem. We can use also the formula xy in terms x tilde y tilde. We can transpose this coefficient minus 1 minus ratio 8, 3 and 2 minus the ratio 4, 3 x tilde y tilde x tilde y tilde plus this coordinate vector. And in the matrix form, using this formula, we obtain xy is equal minus 1 minus minus the ratio 8, 3, 2 minus the ratio 4, 3. Plus the coordinate vectors of the region, of the new region. And this coordinates form for the expression of the coordinate point in the old coordinate system in the term of coordinate of this point in the new coordinate system. And the answer. Any question?
No, thank you.
It's typical problem. And let's pass to the second part of our seminar, but I suggest to some homework problem. It's a more simple homework. Enough more simple. In trapezoid ABCD with BC parallel AD, the ratio BC ID is equal the ratio to 3. Let E be the midpoint of AD. And let the coordinate of the point in the coordinate system S prime E A E B and expressed the coordinate in the old coordinate system A, AB, AC. The similar draw 2, 3, A, B, C, D. E, EA, EB, the new coordinate system, and the old coordinate system A, AB, AC. In my opinion, this problem is more simple than previous, and let's try this problem as a homework. I'll send also the list of the problem, and in this list more hard problem, and some of them is enough simple. In my opinion, is the most simple of this problem. If you understand the solution of the previous problem, you can easy to solve this more simple problem. After that, let's pass to the second part of our seminar, conic section. Maybe any question? Yeah? Okay. I should remark, in this problem, which connect this relation between old and new coordinate system, the main idea of solution, the relation between vectors of old and new bases, and the expression for the new origin in terms of the old basis. If we have this relation, we can use the formula which obtained in the lectures, which expressed the coordinate point in the old coordinate system in the term of the new coordinate system. And if we have such relation, we can use this formula and we can obtain this relation. This main idea, to obtain the sum relation between vectors in the new and old bases. Okay. Part 2 of our seminar. Part 2. Conic section. We need in this formula for canonic equation of the old conic parabola. This formula was obtained in the lectures, in the last lecture. Y square is equal to 2px. Second formula, ellipse. We will obtain this formula on the next lecture. The ratio x square a square plus y square b square is equal to 1. In this formula, p is parameter. In this formula, two parameters, a and b. And we can use also c square as a difference a square minus b square. And the ratio CA is equal E, eccentricity. And the third formula, hyperbola. In this formula, c square is equal a square plus b square, and the ratio CA is also eccentricity. The canonical form on these three curves. Parabola. This D, this D prime. D is the distance between F, which called foci, and this straight line, which called directrix. This case. And we have also second and third cases. Ellipse. C A B minus B. And we have the same figure, and the form of ellipse is following, and we have two directories. This point, the ratio A to E, the ratio A E. E less 1, and the ratio A to E is larger than A, and we have two directories. And D prime, the ratio D prime is equal E less than 1. And in this case, the canonical equation of ellipse is equal we can see from the form of this equation, easy to conclude that ellipse have two symmetry lines, x of abscissa and x of ordinate is a two line of symmetry, because if we change sign x and change sign of y, the point, if point is coordinate x, y belongs to the ellipse, we have from this the point with coordinates minus x, y also belongs, that E denoted by the ellipse. And if point with coordinates x, y belongs ellipse, then point with coordinates minus x, y, x minus y, minus x minus y also belongs ellipse. And we have two symmetry line, axis, coordinate axis, abscissa and ordinate axis. And from the form of the equation, we can easier to see that if x is equal plus minus a, then y is equal 0. And if x is equal, if x is 0, y is equal plus minus b. And we have this point of intersection, coordinate axis with ellipse. And from this equation, we can see that if we change x, if x rise, then up, and the value of coordinate I is down, and inverse. Yes.
What is capital E and big E?
E is this ellipse. Capital E is ellipse. This.
So E, X, and Y are okay. Okay, got it.
We have definition of ellipse as a locus, the initial definition. The ellipse is locus of the moving point, which the ratio distance between this point and fixed point F, which called focus, to the ratio between this point to the fixed straight line is constant, is equal E and E less than 1. This ratio is fixed. And moving point, the locus of this moving point is called ellipse. And ellipse is following form, is the circle which shifted in the direction of the coordinate xy. Coordinate xy shifted.
Excuse me.
Yes.
Why did you write? What did you write in the very last line? X is equal to what?
In this formula.
Yes.
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 It will. We have
below
a small a. Oh, I'm sorry. 0, 0 in this formula. X is equal 0. Then y is equal plus minus b. Easy to see. If we substitute the value x is equal a, we obtain this one is equal 1. And this one, from this we obtain this y square, the ratio y square, b square is equal 0. And from this we conclude that y is equal 0. Easy to see, if we substitute x is equal 0 in this formula, we obtain that the ratio y square b square is equal 1. And then y is equal plus minus b. Yes? Do you understand?
Yes, yes, thank you.
Yes. And we obtain this formula. Let's try some problem using these two expressions. Hyperbola we will consider in the next seminar. Let's restrict yourself only to these cases, parabola and ellipse. First of all, problem 1. Find the equation of parabola given that the focus is 6, 8, coordinate of the focus 6, 8, and the directrix directrix is the line y is equal minus 2. I must stress that this equation is the equation of parabola in the so-called canonical coordinate system. This canonical coordinate system, in this canonical coordinate system, we have the coordinates of the focus plus minus C0, and directrix has the equation x is equal the ratio A. Only in such canonical coordinate system, the equation of the parabola is has the same canonical form. But if we consider the parabola in arbitrary coordinate system, we obtain the other equation. We can assert only that this equation is a polynomial of the degree 2, and that's all. And later we obtain some sufficiently condition for this equation in general form, and calculate some invariant which give us the sufficiently condition for that this polynomial is a polynomial which defines the parabola or ellipse, and it will be later. Now we can assert that this the equation of parabola only the equation of the second order, and enough. And let's calculate this equation of the parabola, which defined by this condition, and we also use the definition of parabola. And our calculation will be repeat the same calculation on the lectures. We repeat this calculation, which did in the lecture in the morning. And we have coordinate system, and point F has a coordinate 6, 8, F. And we have also straight line L. And let's calculate distance d prime between point F and this straight line. And let P be arbitrary point with coordinate. I'm sorry. Let's consider the moving point P and calculate the distance between P and this straight line, and this distance d prime. And let's calculate the distance between P and F, d. And let's R as a lecture be the base of perpendicular which pass from point P to the our fixed straight line A. And easy to see that PR, this distance is equal x plus 2. Oh, I'm sorry. Y plus 2. Sorry, y plus 2. Y plus 2. And PF is equal x minus x minus 6 square plus y minus 8 square. And we have the distance is equal d, and this distance is equal d prime. And d is equal d prime. So y plus 2 square is equal x minus 6 square plus y minus 8 square. And let's calculate left and right hand of this equality, and we obtain y square plus 2y plus 4 is equal x square minus 12x plus 36 plus y square minus 6y plus 36. And we y is cubed, and we obtain the following equation. X square minus minus 12x minus 18y plus 60 is equal 0. This equation, the equation of the parabola. We can rewrite this equation in the following form: x square minus 12x is equal y minus 60. We can simplify left and right side, and we obtain x minus 6 square minus 36 9 sorry. X minus 6 square is equal and easy to see, we obtain x minus 6 square is equal y minus the ratio, sorry, 1. And easy to see that this equation very similar on this equation. If we can define the new coordinate system, x prime is equal x minus 6, y prime is equal y minus after this shift, we obtain the new equation x prime square is equal 18 times y prime. It's very simple on this equation. If we change the coordinate axis, x2 prime is equal y prime, y2 prime is equal x prime, we obtain the following equation: x2 prime square is equal, and easy to see, the parameter p in this case is equal 9, is equal 9. And we can compare our calculation with if we choose the coordinate system by canonical way, we obtain in this canonical coordinate system this canonical equation of the parabola. But in the arbitrary coordinate system, we obtain other equation. In this case, we can see that this equation, we can see that the term y square is absent in this equation. Only this fact we can see in this equation. Maybe a question? Any question?
Sorry, Professor, if we draw the parabola right now, is it going to be like horizontal or vertical?
Yeah. In this case, this parabola is not horizontal. We can draw this parabola. This for. Let's try the parabola. This line is a directories. This 6, and I'm sorry, maybe my mistake. 6, 8, and this distance is equal 10. Maybe, I'm sorry, maybe mistake. Mistake. 4y, and in this equation 20. Mistake. Because this distance is equal 10. This distance is equal 10. This values 2 times p, and this distance is equal p. P is equal 10. Five. This point with coordinates 6, 3 is the vertex of the parabola, and the parabola has the same form. This form. And we can if x is equal 6, this expression is equal 0, and y is equal sorry, 2 I'm sorry, P2, the region is the middle of this 2 and 8. X is equal 6. I'm sorry. Maybe. Excuse me, maybe. X is equal 6, y is excuse me, my mistake, plus 96. Excuse me. Hmm. 64, other mistake. 64, y minus 5. It's right. This formula is right. Excuse me. This mistake, and we can see this mistake. Also, we draw this parabola. This is exactly formula y minus 5, and this kind of this parabola is the following. The coordinates of the vertex is equal 6, 5, and easy to see that this coordinate fx is equal 6, the left hand is equal 0, and in this case y is equal 5, and right hand also equal 0, and we obtain the coordinates of the vertex of the parabola. And this transition from the old coordinate system to the new coordinate system, and this new coordinate system, we obtain this equation of the parabola, and after changing coordinate axis, we obtain the canonical equation for parabola. And the canonical equation has the following form. I'm sorry, 20x prime. We correct mistakes, and this answer is right. Thank you for attention. Any question, maybe?
No, thank you.
Thank you.